Hi, in this video, I'm going to explain about epidemiology. So do subscribe Medicines Made Easy for medical students, and please go to medicinesmadeeasy.webado.ie if you want to get this slide. So before that, I just want to start off by introducing epidemiology. So you have two types of epidemiological studies. You have descriptive and analytical. So descriptive might include the disease occurrence and disease distributions, while analytical will be disease determinants. Remember, epidemiology, our focus is on human populations and is not on individuals. So next, we move on to measure of health. So how we measure health, we look into their life expectancy and we look into self-perceived good health. So for self-perceived good health, we are gaining the perceptions from an individuals about their own health and how they rate their own health, whether it's 100% in good conditions or only 20% or 30%. It depends on individuals' perceptions on their own health. Well, for quality of life, it's like a scoring system. So we require the participants to answer the survey, and each different answers will be given marks. So then we total up, we calculate, and we sum up the total of the score that is achieved by the persons, and we put into categories to determine the quality of life of the individual. So the last bit is we are looking into the disease occurrence or the disease frequency and how we measure it by using statistics. So first thing, I just want to differentiate the difference between incidence and prevalence. So both methods are used to measure the frequency or occurrence of a disease. So what is the difference between incidence and prevalence? So in this case, incidence, we are looking into new cases at that particular point. This means we do not include the existing cases. So the denominator of incidence rate would be population at risk. So population at risk can be defined in a number of ways. Either it is based on gender, based on age, or based on the total populations in that area. However, for prevalence, we include both new cases and the existing cases at that particular point, and the denominator would be the populations in that area. So then we move on to the sources of information. How we get the numerator, how we know the disease occurrence in that particular populations, how we know. So we gain the data from the National Cancer Registry, or you can gain the data from HIPI, which is Health in Patients Inquiry. So this is the hospital-based data, and the last bit you can have the data from the Health Protection Surveillance Center. So mortalities and morbidity is similar to the disease occurrence, disease frequency, in which we also use the formula of number of cases divided by the population. So it's always cases over population. So for mortality, it's just the number of death cases over the populations, and for morbidity, it's the number of cases in terms of the illness over the populations. So causation, remember, causation is not correlation. So what is correlation? So correlation is the measure of the strength of the linear relationship between the two variables. And remember, these two variables must be quantitative. It's not qualitative, it's quantitative for correlation. So the model to test, the ancient model that we use for causation is Koch postulate, ancient model. So Koch postulate, we are describing the relationship between the microbes and the diseases. So this means that you must have a microbes in order for the disease to occur. That is Koch postulate. So causations can be divided into two, like benefit factors and risk factors. However, the benefit factors and the risk factors cannot be concluded as the causation. Why? Because let's say we take as example of risk of getting lung cancers among the smoker. However, this doesn't mean that those smokers will get the disease. They just have the risk. So that's why causations cannot be concluded whenever it comes to benefits and risk factors. So the classic epidemiological triad, it includes the three components of causes, which is your classic agent, host, and environment. So remember, the classic epidemiological triad is not applicable to multifactorial diseases like the cardiovascular diseases and cancer. So remember, agent is like a toxin and vector is like a transportation to transport the toxin from one place to the host. So remember, agent is different from vector. Agent is the things that cause the disease, and vector is the thing that transport the toxin. So for host factors include individuals' behavior, lifestyle, genetics, nutritional underlying conditions, immune systems of the person, the psychological makeup, and ethnicity, comorbidity, age, and gender. So comorbidity in this case means you have a primary conditions with adds-on of secondary or tertiary conditions. That means you have more than one disease that is occurring at the same time in an individual. That is comorbidity. So environmental factors. So for environmental factors, we can use the BISPOS. So these acronyms is useful for you to remember what are the environmental factors. So you can have biological. So biological in terms of the insects that transmit the agent, or you can say like something like mosquito. So that is biological agents. So that is the biological factors. So infrastructural, we are referring to the place you live in, the infrastructure that is available in your community. And for social environment, and you have physical factors. Accessibility, we are referring to accessibility to healthcare. And legislative, we are referring to the law or some legislations in your country. And you have socioeconomy. So multifactorial. So just now we mentioned that classic epidemiological triad is not applicable to those multifactorial diseases. So what happens is that you will have component causes such as sufficient causes and necessary causes. So these three multifactorial component causes, multifactorial is the multifactorial diseases. So we look into the components of causes that cause these multifactorial diseases. So first thing we include the host, the environment, and the agent. So these three things are the components of causes. Okay, so component of causes divides into two types. One is sufficient causes, the other is necessary causes. So now we move on to the component of causes. So component of causes can be broken down into three things. So to remember, the acronym is PEPR, which is similar to pepper. So you have first is a predisposed. So predisposed is susceptibility to a certain disease. For example, like you are older or you are younger. So predisposed is similar to susceptibility. While E is referring to enabling. So enabling, you just imagine ability. Your ability to afford the medical costs, the health costs, in order to get treatment. So that is enabling. So how about P, precipitate? So another P, precipitate, is exposure, your exposure to the disease. That is P. And finally for R is reinforce. So reinforce means the add-on effect from other factors. That means such as you put on stress, you are increased susceptibility to the disease when you have a reinforcement such as stress or any other psychological effect. So that is reinforce. So first, public health will block any single component that is sufficient cause. So sufficient cause is the cause that might be accumulated over time and is sufficient to cause the disease. So public health will try to prevent or control the disease by looking into the sufficient cost and how can we reduce this sufficient cost. So you have two types of epidemiology. So descriptive epidemiology, they are focusing on generating the hypothesis, while analytical epidemiology, they are focusing on testing the hypothesis. However, in analytical epidemiology, we are looking into comparisons of two groups. Okay, so the study designs for epidemiology, such as the descriptive epidemiology, you have case report. So we are not comparing anything, we just report the cases that we discovered. So correlational studies, or what we know as ecological study, as a group but not individual. So remember, correlation is different from association, because correlations, we are looking into the quantitative variables to quantitative variables, while associations, it can be the combinations of quantitative or qualitative variables, or can be qualitative variables alone. And correlation, we are looking into the strength of the linear relationship. And association can be anything, any relationships between the two variables. While the last part would be the cross-sectional studies, which is the prevalence study. So remember, cross-sectional study is a snapshot of the populations at a point in time. So we are looking into the prevalence of the disease at that point in a time. So these three things are included in descriptive epidemiology. While for analytical epidemiology, it is divided into two. One is the experimental study, and another one would be the observational study. So for experimental study, we include clinical trials, field trials, interventions, and intervention studies. And for observational studies, it could be case control. For example, retrospective. So retrospective, in this case, we're looking back. So we choose the person, the exposed group, which has the disease. They have the disease, and we look back into their history. That is retrospective. Cohort study would be follow-up study or longitudinal study. So your cohort group or your sample must be disease-free at first, and then we follow their course, their journey in future. Whether they so we have two groups, one is exposed and unexposed. And for cohort studies, we are looking into whether the exposed group will develop the disease in future. So association studies is also part of cross-sectional study. Remember, association is not equivalent to correlations. So last part will be the Bradford-Hill criteria for causation. So this is the criteria to assess the degree of causations. So to remember this criteria, there is an acronym that you can use, which is TB, tuberculosis, PACE, the severe coughing scenario. So these 9 criteria are the essential components to assess the degree of causation. So that's all from me. Please subscribe Medicines Made Easy for Medical Students, and thank you.